Okay, so welcome to the video. And so today we're going to be looking at trigonometry. And the questions that you see here actually come from a past paper, the 2018 November past paper, grade 10. And so I'd like for you to, if you want to get those papers, you can go on to the government department and download it and actually look at the answers as well. So other than that, let's begin. So we have question 3. And in question 3, basically, it's trigonometry. And so it says 3.1. In the diagram below, there is a triangle, and this triangle is called QPR, and it is a right angle triangle. And we also see that QPR is equal to 90 degrees. And so automatically, because it is a right angle triangle, with trigonometry, we associate trigonometry with right angle triangles because remember the ratios themselves are actually equals to the opposite side over adjacent, the opposite side over the hypotenuse, or the adjacent side over the hypotenuse, right? So the first question there, it says at the bottom there, 3.1.1, it says use the sketch to determine the ratio of tan 90 degrees minus r. Now, if you look at this particular right angle triangle, QPR, notice that in actual fact, P, remember, is 90 degrees. And then we have R, an angle R. They didn't give us a value for angle R, but we have R as an unknown angle, and we also have Q as an unknown angle. But if you think about it, 90 minus R, if you think about it with geometry, remember that all triangles are a sum of angles, right? This is the sum of angles. So basically, then we could say, notice that when we say Q, the angle Q plus the angle R plus the angle P is equal to 180 degrees because it is the angles of a triangle, which are supplementary, right? Then if we substitute in what P is, it is 90, and we don't know what Q and R is. What are we trying to actually do here? We are trying to figure out what is 90 degrees minus R. And so how could we figure out what 90 degrees minus R is? We can just try and rewrite it, right, and manipulate this equation so that we have on one side where we have 90 degrees minus r, and that's what we get on this side, right? And 90 degrees minus r basically means that that is all equals to q. So in actual fact, this tan 90 degrees minus r is the same as saying that it is tan q, right? So they're actually looking for tan q. So if that's the case, then when you look at tan q, take into account that this is q there, and you're looking for the tangent of it. And the tangent, what does it mean? It is the opposite side to the angle over the adjacent side to the angle. Basically saying the opposite side to the angle and the adjacent side, or remember, adjacent means next to the angle, right? And so basically then you have that it is PR over PQ, or QP and PR, right? So that's what we actually have, PR over QP, right? And that would be your answer there. And then when they actually ask us, write down the trigonometric ratio that is equal to QR over QP. So QR over QP. Now, if you think about it, if you look at the information that they've given you, they want you to write down the trigonometric ratio. Now, you need to just work backwards, right? In the first question, we were working kind of forwards because we had the trigonometric ratio and we just wanted the fraction in which it is represented, right? So in this case, now we're looking at the fraction that it is representing, a trigonometric ratio, and we want the trigonometric ratio. So let's look at these two lengths, which is QR and QP. So which one is QR and QP in this case? If you notice, there's QP and there is QR. But QP and QR, if you think of it, if you wanted to, you could say this angle here has the adjacent side QP and the hypotenuse QR. And remember, how can we see that QR is in the hypotenuse? It is always directly opposite the 90-degree angle. So it is directly opposite the 90-degree angle. So we 100% certain that QR has to be a hypotenuse, and therefore we can say that we can see that QP, if we write the normal trigonometric ratio where it is QP over QR, which is the adjacent side over the hypotenuse, that gives us the cos Q, which is the angle in between these two sides, right? Cos Q, right? And so if it's cos Q, remember, this is not actually what we are trying to show, right? We have what we need, which is basically QR and QP. But now the only issue is that we need to have QP as the denominator. So we need to get QP to be the denominator and QR to be the numerator, right? So how could we do that? Remember, if you swapped everything around, you would actually see that the cos would become 1 over cos theta, and QP would become the denominator and QR the numerator, right? And so from there, we know that 1 over cos theta is basically sec theta, right? Which is just the inverses of each other, right? And so sec theta is the trigonometric ratio that they are looking for. Okay. And then we have 3.2. So now with 3.2, they say S is a point on the Cartesian plane that OS makes an angle of theta with the positive x-axis. Now, what does this all tell us? It tells us that we have a point, a coordinate point, which is -3 and -4, meaning we have our x there and we have our y. And then they also tell us that we have OS, but OS stands for from the origin to the point S over there, right? So that is OS. And then it makes an angle with the positive x-axis, meaning they are measuring it from the positive x-axis to the OS, right? To OS. Okay, but the first question the instruction is that calculate the following without using a calculator. So the first question, which is 3.2.1, it says the length of OS. Now, where is OS? S is the length that they're looking for. But notice now that in truth, if you notice, this actually forms a right angle triangle. How? Thinking about the coordinates themselves, how do we map coordinates? Since it's -3 and this is x, it means that it moves -3 times to the left. Right, it moves -3, right? It's -3 over there, right? It would be x -3. If x is equal to -3, then we would have drawn a line that goes straight down like that, right? So that's -3. That is -3, but then it's not -3, but it's actually 3 units for moving from there to there, right? There's 3 units. And then we also see that we have -4, hence from here to there, then it is -4. But this actually forms what? A 90-degree angle. How? Because this line going directly down is actually parallel to the y-axis, and if it's parallel to the y-axis, it would create a 90-degree angle. And so this OS that we are looking for is actually a hypotenuse. And so if that is the case, that this is the hypotenuse of this right angle triangle, then it means that we have to just say OS to the power 2 is equals to -3 all to the power 2, which is your x, plus -4 all to the power 2, which is your y, and that would give us 9 and 16, and when we add them together, we get that will be 25. But then we are not looking for OS squared, but we're looking for just OS, so we square root on both sides, and the square root of 25 is just 5 units. So basically, the length of OS is 5 units, right? So it's 5 units. And then continuing on the question, it says 3.2.2. then they ask us the value of secant theta plus sine theta. So the first thing that you should probably do is that you must convert the sec theta, right, the sec theta over there, sec theta plus sine theta into a more simplified version. Now sec theta is actually 1 over cos, right, which are both inverses of each other. And then also at the same time, sine 2 theta, or sine to the power 2 theta, is actually sine theta all to the power 2, and as you can see in the bracket over there. And so from here, what can we do? The only thing we need to do, we need to identify what cos theta is in the diagram and sine theta what it is in the diagram. So if you go back to the diagram, what would cos be? Now cos is the adjacent side over the hypotenuse. So the adjacent side over the hypotenuse of this triangle measuring this angle here, then it would be the -3 and 5. So it's -3 over 5, as you can see, -3 over 5 over there. And so if that's the case, then we just need sine theta. So if sine theta is the opposite side over the hypotenuse, so then we would have -4 over 5. So then it's -4 over 5, and we have what we need. So from there, then you can just bring back the expression that they want you to find the value for, and then substitute those values. Now notice here we have 1 over cos theta, but then remember cos theta is -3 over 5, but I wrote 5 over -3. How did this happen? Remember, 1 over a fraction where it is -3 over 5, what would happen is that the 5, which was a denominator in the original one, would become a numerator, and then -3 would leave it underneath. And that's what happened. So we have 5 and -3 at the bottom, and then -4 over 5 basically is all to the power 2. So therefore -4 to the power 2 is 16, positive 16. 5 to the power 2 is 25, and then we have 5 divided by -3, and then you can calculate this by multiplying 25 on both 25 on the numerator and denominator for this fraction, and then for the other fraction we can say it's -3 over -3, and that would be -16 times -3. That gives us -48, and then we also have here 25 times -3. Now 25 times -3 is supposed to give us -75, not just 75, but -75. And what we would get in that case then is that once we subtract 25, which came from 5 times 25, that gives us 125 minus 48, that gives us 77, but it is -77 over 75, right? So that would be your answer for the secant theta plus sine square theta, right? And then the last question here, so it actually says determine the value of the following without using a calculator. So in this case, then they actually give us this where it is cosec 45 degrees all divided by sine 90 times tan 60 degrees. Now here, whenever you see a special triangle or a special angle, which is 45 and 60 and 30 degrees, then you should have automatically in your mind the special triangles, right? You must draw in the special triangles. So there we have our special triangles, the 60-30 degree triangle, right? And the 45 degree special triangle with the values of 1 and 1 for the 45 and square root 3 and 1 for the 60 degrees, right? Now the only thing now you have to do is just to simplify this nicely. So we have cosec 45 degrees, which is a numerator, so that's why it's ahead. Then it's divided for the fraction line, and then the denominator at the end, which is sine 90 degrees times tan 60. But sine 90 degrees is actually just what? It's actually just 1. So then we have 1, but then we have tan 60 degrees. So we go back to our special triangle. So tan 60 degrees is the opposite side divided by the adjacent. So then if it's the opposite side divided by the adjacent, then we would have its square root 3 over 1. And then we have here that cosec 45 degrees, remember, is the inverse of sine. So it's 1 over sine 45 degrees. And if it's 1 over 45 degrees, remember, sine 45 degrees, we look at this 45 degree special triangle. And the 45 degree special triangle for sine would be 1 over 1 of square root 2. But this is similar to what I had said above. This would move into the numerator and this would stay as the denominator, and that's why we have square root 2 over 1 divided by square root 3 over 1. However, now you have two fractions that are, we have a fraction division, and we can't do fraction division. What we have to do is that we must change the division sign into a multiplication sign, and after changing this to a multiplication sign, we have to change the denominator into the numerator, and the numerator into the denominator, right? And basically then we have 1 over square root 3 times square root 2 over 1, and 1 times square root 3 is just square root 3, and square root 2 times 1 is just 2. So that is the video for you. But again, some few points that I just want to highlight is that, please, in this case, especially here, always have in mind Pythagoras, but also have in mind some of your trigonometric, your geometry theorems. For instance, the one that we used here was the sum of angles, right? Which was quite useful for us to actually see what this 90 degree minus r is. So other than that, I really hope that this video is helpful, and I'll see you next time.